What's today? September 22nd? All right. Chain rule. Hashtag calculus cardinals. I don't know. Next time we'll do a better hashtag. Let's see. We know how to differentiate sine x. We know how to differentiate x squared minus 4. But what if we have a composite function like sine of x squared minus 4? So that's where we got the chain rule here. And then we'll talk about what the chain rule is. So check it out. We're going to do a derivative first just by doing it like this. So the function y equals 6x minus 10 can be written as, if you factor out a 2, 2 times 3x minus 5. And that's a composite function. If you say y equals 2u and u equals 3x minus 5. So how are the derivative of all three functions related? Well, let's do this one first. If y equals 6x minus 10, what's the derivative of 6x minus 10? 6. Perfect. Nothing crazy. It's just that. Are we still okay? All right, well, what if we have it like this? What if we have y equals 2u, and we know that u equals 3x minus 5? Well, here's what we're going to do. I'm going to take the derivative. Well, what do I want? First, what do I want? I want dy dx. So that's my big hint. So right now, this is y, but it's in terms of u, not x. Do you guys see that? So when I take the derivative of this will only give me dy du. So dy du is 2. Are you okay with that? Okay. Look at this one here. This one has a u in the front, and I have an x there. So I can only take the derivative of this one. This one's going to look like this. Du dx. And what's the derivative of this with respect to x? 3. I want you to observe, guys, if I want dy dx, that's the same thing as saying dy du times du dx. Of y. Notice that if I multiply dy du times du dx, look what cancels, the du's. Do you guys see that? And you're left with the dy dx. So dy du was 2, du dx was 3, and OMG, are you shocked that I got the same thing that I did over there? No, because that's what we know. So now that you guys know that, this right here is the chain rule by definition. And the dy du is kind of like the derivative of the outside. And the du dx is like the derivative of the inside, because that's like your argument. So that's what you're going to start saying. Derivative of the outside, leave the inside alone, times derivative of the inside. But don't worry, we're going to practice a whole bunch. I used to give M&Ms out, but I haven't been giving M&Ms in a while. It's related. Like work your way outside in. You know what I mean? So let's do it again. So check it out. I have this function. 9x to the 4 plus 6x squared plus 1, and it can be rewritten like this with a 2 on the outside. See? Child, I don't believe you. Well, look. 3x squared plus 1 with a square on it means, see? Well, no, just in case. 3x squared times 3x squared, 9x squared. 3x squared times 1 is 3x squared, but I'm going to have how many of those? Oh, 9x to the 4th. My bad. Plus 6x, 6x squared. 3x squared times 1 is 3x squared, and you're going to have 2 of those, so 6x squared. And then 1 times 1, 1. Is that the same as this? Yeah, it's still morning for me. All right. I think everything's okay. I think we're good. Let's first just take the derivative of this guy, just general, like that. Y prime, what's the derivative of 9x to the 4th? 36x cubed plus 12x, and then that's it, right?
Why do you have to do the chain rule? You can just do it that way?
Yeah, for this one, you would never do chain rule on this. You would just do it like that. But I'm just showing you that it works. You know what I mean? That's the whole point of these two examples. All right, so now let's say we do y equals u squared, where u equals 3x squared plus 1. So now look, I'm taking the derivative of y with respect to, no, that's a u. And the derivative of that is 2u. Are we okay? All right, so now I'm going to take the derivative of this, du over dx. And the derivative of that is 6x. All right, so now if I were to say, what is dy dx? Well, dy dx is dy du times du dx. See? The u's cancel out. So dy du, so 2u, don't worry, we'll replace what u is in a little bit, times 6x. Are we still okay? We know that u equals, perfect, so 2 parentheses 3x squared plus 1 times 6x. Do you guys want to multiply the 2 and the 6x already? So maybe I should have done it right here. What's that? 12x parentheses 3x squared plus 1. Are we still okay? 12x times 3x squared. 12x times 1. OMG. Are we shocked that we have the same derivative as when we took the derivative of that polynomial? Oh. So that's chain rule. This right here is chain rule. Derivative of the outside, leave the inside alone, times derivative of the inside. That's what we're going to start doing, guys. Just derivative of the outside, leave the inside alone, derivative of the inside, chop. What do you even mean by that? Okay. So if I tell you, let me change the color again because I'm doing it different. D dx, giant parenthesis, little parenthesis, 3x squared plus 1, close it, squared, close it. All right, I'm going to go slow, guys. That 3x squared plus 1 is considered like inside. Inside. So what's on the outside? Well, the outside is this parenthesis which raised to the power 2. So derivative, take the derivative of the outside, bring the 2 to the front. 2, leave the inside alone. To the power 1. Do you guys see what I did? Yeah. It's like if I were doing power rule. Times derivative of the inside. What's the derivative of 3x squared? There it is. 6x times 2, that's 12x. And I'm multiplying it by 3x squared plus 1. And look at this. 36x cubed plus 12x. OMG. Another way, same answer.
Would you recommend, like, you know how they found 2u and then we found 6x? Would you recommend doing them separately and then bringing them together?
No, we're probably going to do it like this all the time. Okay. How do we feel? Does everything make sense, guys? All right, here's the chain rule with the formal definition. See, if f is differentiable at the point u equals gx and g is differentiable at x, then the composite function f composite of g is differentiable at x. Derivative of the outside, leave the inside alone, times derivative of the inside. In Leibniz notation, blah, blah, blah. Everything, yeah. We'll do it one more time. Did I put it here? Let's try example outside, inside. Okay, so, all right. An object moves along the x-axis so that its position at any time t greater than or equal to 0 is given by x of t equals cosine of t squared plus 1. Find the velocity of the object as a function of t. Ooh, I don't even know if we have enough experience to know that. What's the derivative of position? The derivative of position. I don't know if we have enough experience to know that. The derivative of position with respect to time. Yeah. What's the derivative of velocity? No, you just guessed? No critical thinking at all? Yeah, okay, guys, time out. Think about what a derivative means. It's an instantaneous rate of change, yes or no? So if you take the derivative of a position time graph, a derivative of a position, think about what you're doing. You're finding an instantaneous rate of change. Well, if the y-axis is position in meters and the x-axis is in seconds, if you're finding an instantaneous rate of change, you have meters per second. It's a slope. It's a tangent slope. Instantaneous rate of change. Does that make sense? So if you find the derivative of position, you get velocity. Speed, if you want to call it absolute value of velocity. Does that make sense? If you get the derivative of velocity, what is that? Think about it. The y-axis, I don't know, make up some units, meters per second. Y-axis in meters per second, the x-axis in seconds. So find the rate of change, the difference in y is meters per second divided by seconds. What is that going to give you in units? Meters per second, or the same thing as meters per second squared. What is that? Acceleration. So let's see what we just discovered right now. The derivative of position is velocity. The derivative of velocity is acceleration. There is something that's the derivative of acceleration, but we're not there yet. So we'll wait for the end of the week for that. All right. So maybe I'm missing a lesson that I should have done before. All right. The derivative of velocity is acceleration. Take derivative. So we need more experience, but we'll figure it out. We'll do some more experience tomorrow. We'll probably do like a mini lesson, and then set you guys loose. No more than 10, 20 minutes. All right, here we go. I'm going to go, come on, Amos. So we're going to say dx dt, that's what I want, is equal to, so here's what I'm going to do. I'm going to say that u equals t squared plus 1. So then I have cosine of u. Have I confused anyone? I did? Yeah, I just said, see what I said here? U equals t squared plus 1. Look what I have. So x, I have x, I guess now I have it in terms of u. I don't have to write x of u, I can just write x. So I have x equals cosine u. And u equals t squared plus 1. Okay. Did I still confuse you? Okay. I'm trying to do the chain rule. I want to use this right here. So I can do this, dx du times du dt. And then the du's cancel out and I have dx dt. Yeah. Well, I don't have to call it u, I can call it w. Well, because it's a composite function, yes. Right? I can call this any letter I want. I wouldn't call it x because of x equals that. I don't have to do it this way. You don't have to. You can do it the way we... All right, so here we go, guys. Here we go. dx du. What's the derivative of cosine? Negative sine. You got to keep the argument. Negative sine u. Are we okay? Of x with respect to u. What is du dt? 2t. Perfect. So my dx dt is nothing more than dx du times du dt. Are we still okay? All right. Dx du is a negative sine u, and then du dt is just 2t. I want my derivative to just be in terms of t, so I'm going to write dx dt equals negative 2t sine of t squared plus 1. Maybe I'm being extra. Maybe I should have just taken the derivative the way we're about to do it right now in the next example. Maybe I'm stubborn and I'm like, I want to do this dx du times du dt no matter what. Say it again. That's my argument, right? T squared plus 1. Oh, ask me, miss. We're good? All right. Here it is. So maybe you'll like this better. Maybe you'll like this better, Vega. So look what chain rule is. It says derivative of the outside, leave the inside alone, times derivative of the inside. And that's actually how you say it. In words, differentiate the outside function f and evaluated it at the inside function g of x left alone, then multiply by the derivative of the inside function. Okay, so here we go. So I'm going to go d dx. Is it an x? No, it's a t. I'm just going to write the x of t. X of t equals cosine t squared plus 1. The argument, t squared plus 1, is considered the inside. Plus, you can't change your argument anyways. You guys ready? All right, so I'm going to write dx dt. You can, if you want, put a t right next to the x like that. That just means with respect to t, but it's understood, so we just dx dt like that. I'm taking the derivative of x with respect to t. What's the derivative of the outside? So I'll write negative sign, leave the inside alone. I mean, you have to in this case because you got a trig function, so you got to leave that inside alone anyways. Am I done? Times derivative of the inside. What's the derivative of t squared plus 1? 2t. So then rewriting it, dx dt equals negative 2t sine of t squared plus 1. Say it again. I wouldn't call it simpler. It's the same. It's just we're doing it immediately instead of like separating it. You guys ready? Differentiate. I'm going to pass back all the papers I have for you guys so far. Some of you guys on the circuit, you're calling, before you even evaluate it, you're calling it derivative. Notation's important, guys. You can't be saying, like you can't be going y prime sine x squared plus x, and then take the derivative, cosine, blah, 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 whatever. You guys, some of you guys don't have really good habits, so try to fix that if you can. I put feedback in there. All right, don't worry, I'll give it back to you guys. All right, here we go. Differentiate. So what does differentiate mean? Take a what? Derivative. So here's the proper notation. d dx, and with respect to x, open parenthesis, sine of x squared plus x, close. So that is telling me that I got to take the derivative of this expression. Chop, why didn't you put dy dx? Well, they didn't tell me that this was y equals. So if they don't tell me that it's y equals, I'm just taking a derivative with respect to x. Does that make sense? Yeah, they just said sine, differentiate this. If they would have told me y equals that, then I would have put a dy dx on the top. All right, here we go. What's the derivative of sine? Cosine, leave the inside alone. I mean, you have to because it's a trig anyways. So in a little bit, we'll change it up. Times derivative of the inside, which is plus 1. There it is. I would leave it alone like that, unless you want to put this in the front. So 2x plus 1 in the front. There it is. Cosine of x squared plus x. Parentheses are important. Some of you like to get the parentheses to disappear. So, okay, listen. Don't write this down. Just listen. If I delete these parentheses, is it still the same? No, it's 1 times that. So, guys, parentheses are your friend. Make sure they put parentheses all the time on these. Cool? Put parentheses. Or else. All right, here we go. You guys ready? I promise YouTube, this is a safe space. My kids are happy, I can assure you. You guys are happy, right? No. All right. She's kidding, guys. All right. Yes, you're 100% joking. LOL. Find the derivative. They told me that this function is g of t. Here we go. You guys ready? G prime of t equals, what's the derivative of tan? Just secant squared. If it starts with a c, it's negative. Yeah, see, you guys need to, before you go to bed, before you do your prayers, you got to look at that sheet. All right. Secant squared. This is my argument. So leave it alone. 5 minus sine of 2t, close. Are we still okay? Am I done? No, times the derivative of the inside, but notice this one has multiple insides. That's sine of 2t. What's the derivative of sine? Cosine, but I have a negative in the front, so I need to keep the negative. Cosine of 2t. Does that have an inside? What's the derivative of 2t? Times 2. Does everyone see what we did? You can keep the parentheses on everything if you want. Like that. If you want to do that. You don't have to.
This is so silly.
So here we go. What is this if I rewrite it? G prime of t equals, let's see, I have a negative right here and I have a 2 there. So I'm going to write negative 2. I'm going to put the cosine first. Cosine of 2t, close, secant squared of 5 minus sine 2t, close. Well, I already multiplied it. Negative 2 cosine 2t. Right?
Sure.
You can if you want. Not a big deal. It won't hurt. Negative like that. That's fine. You can if you want. You don't have to, though.
I don't like this.
Why? It's not even that bad. You're going to be doing this all year. There's the last rule that we're learning. Now we're just going to take derivatives galore forever and ever and ever and ever and ever. For the next 1,000 years.
Are we going to have adults after this?
Yeah. Was that it? I thought I was going to use more. Dang, look at all that white space. Okay. I thought I was going to use more space, but I guess I didn't. All right. Example 6. Relax. It's not even going to be that bad. Look how fast we're going. Look, we're already on page 3.
It's been 30 minutes.
Find the slope. It's because I'm not being efficient. Find the slope of the line tangent to the curve, y equals sine of the fifth x at the point where x equals pi over 3. They just want the slope. They don't want anything else. How do I find slope? Take a derivative. Yeah, they don't want the tangent line. They just want the slope. Does that make sense, guys? All right, so here we go. Before I do anything, I'm going to rewrite this so you guys know how that looks. That is this. Parentheses, sine x, close it to the 5th power. Are we aware of that? Okay, so here we go. I want the derivative of pi over 3, so I'm going to write y prime equals, what do I do first? 5. Perfect. 5 parentheses sine x. Close it to what power? 4. Am I done? No. Times the root of the inside. What's the root of a sine x? Cosine x. Are we okay? All right. I'm going to plug in. Oh, what happened? I did the derivative of the outside. I left the inside alone. The inside this time was sine x. And then I multiply by the derivative of the inside. The derivative of sine x is cosine x. Do you want me to do this? U equals sine x. So then I have y equals u to the 5th. And u equals sine x out here over on the side. I guess that's up there. And then dy du equals 5u to the 4th. Du dx equals cosine x. So dy dx equals dy du times du dx. I can do this. We can do this like this, but look. I mean, I don't know if you want me to. Oh, then what u is with sine x.
How do you know this point?
Say it again.
How do we know you use this point?
How do we know that u is sine x?
How do you know you use this rule?
Oh, because I have an insight. And I want to take the derivative.
But I swear we just used to do like 5 sine and 4 x and then yeah.
Okay, if I have, you're confusing. If I have this, the derivative of that, that's just taking the derivative. That's 5 cosine x. I have the 5 in the front. This is an exponent. That's like saying, what's the derivative of x to the 5th? You said y prime 5x to the 4th. But this time it's more complicated because my inside is sine x. So what's the derivative? Bring the 5 to the front. Leave the inside alone. Because look, the inside is a variable. It's x. Sine x to the 4th power times the derivative of the inside, cosine x. I mean, unless you want to, I mean, there's so many ways to look at it. Unless you want to say like, oh yeah, we've been using the chain rule all this time. If you say that y equals x to the 5th and you go dy dx equals 5x to the 4th, and I took the derivative of x with respect to x, dx dx, but I don't know. I don't know how much you know. I don't want to confuse you. Like this? Yeah, that's fine. Well, we haven't even found the value.
We plug in now.
Yeah, plug in pre-calc. 5.
I hate pre-calc.
Miss, stop. Pi over 3, close it to the 5th power. Oh, 4th power. Miss, you can do this. Sine of pi over 3. What's cosine of pi over 3? Let's see what this is. 5. Square root of 3 times square root of 3 is 3. And 3 times 3 is 9. There it is. 2 times 2 is 4. And 4 times 4 is... Does everyone see how I got that? Times half. When you multiply everything, 9 times 5. 45. 16 times 2. 32. There it is, guys. You just got to practice. Work your way from the outside in. Pretend you were, what's those lollipops that have like something in the middle?
Tootsie Pop.
Yeah, Tootsie Pop. Like, pretend it's like a Tootsie Pop, or I don't know, maybe an M&M. This is why I say M&M. Pretend like you're eating an M&M, but you're somehow eating the outside in. So you eat the shell first, then the chocolate, then the peanut. That makes sense?
Like a Kit Kat. Whenever you eat the chocolate, and then you
Like a what? An elephant?
Yes.
How?
No, I'm just saying, like,
I don't.
if you were to eat an elephant, you would go outside of you.
Okay. All right, here we go. I want to take the derivative of this expression, 1 over 1 minus 2x to the 3rd power. You're not going to do quotient rule. You have a constant on the top. Bring the 1 plus 2x to the 3rd power up. So here it is. Look, I haven't taken the derivative. 1 minus 2x to the what power? Yes. So now your algebra is getting better. Are we okay?
Your algebra is getting better. Crazy work.
No, your algebra is going to be super good by the time we end this. All right.
He said it has to be.
Here we go. Equals. Now I'm taking a derivative, so I'm no longer going to write ddx because I'm taking the derivative. What do I do first?
The -3.
-3. Leave the inside alone. What power? -4. Am I done?
No.
No. What's the derivative of that inside?
-2.
There you go. Probably fix it the way they had it. What's negative times a negative?
Positive.
So positive 6 over 1 minus 2x to the 4th power. How do we feel?
This is so funny.
All right, here we go. Oh man, I keep forgetting to insert the survey questions or the. That's fine. See if you guys can figure this out. Take 2 minutes for question number 1. Take 2 minutes for question number 1, guys. Give it a shot. All right, let's see. What is the derivative of tan? So I write secant squared of 4x. Am I done?
No.
Times the derivative of 4x, which is? So y prime equals 4 secant squared of 4x. What's my answer?
E.
Can we do that? Okay. Yes. Go to the next one. Can you come in, Miss Lam? Take 2 minutes. Give it a shot. No, you're fine. What's today's date? No. Well, actually, I have 2 10th graders.
Oh, really?
Yeah.
Oh, yeah.
That should be it.
Thank you.
Thank you. Thank you, Lam. Sorry it didn't go down there. All right. The first thing I would do if I were you guys is rewrite this. That's what I would do. Unless you're already a pro, then you can just take it immediately. What's your first move?
Move over the 2.
Move the 2 down. Giant parenthesis, all this again. To the power 1. I guess you don't need it. And now what's the derivative of cosine? So negative sign, you keep the argument. And now, am I done?
No.
The derivative of this inside, which is?
3x squared plus 2x.
All right, there it is. I would put the negative, this is all being multiplied. I would put the negative in the front, and then I would start with that one, the polynomial. Y prime equals negative 2, parenthesis, 3x squared plus 2x, close. Cosine x cubed plus x squared, sine x cubed plus x squared. And there's actually a property they can use, but it doesn't look like they did that.
Nobody asked.
Hey, relax. Stop. Be nice.
She's not nice to anybody else.
What's the answer, guys? Yeah, there's no bullying. Stop.
Wait.
Okay. How are we feeling? What's up? Well, it says squared right there. That's cosine squared. So
Oh,
that
yeah,
means
that's
that.
Oh, that's a steroid.
The 2 is right after the s. So that means the cosine squared.
Right.
So that means that. I haven't taken the derivative here. That's just a rewrite or put down. That means that. And now when I take the derivative, should come down. This alone, where it is, oh, that's a power 1, not a prime. It's a power 1. And the derivative of cosine is negative sign, you leave the argument alone. And then we still have this argument of that. You know what I mean? Why is that 2 in the final equation?
Yeah, why is the whole thing in our equation? And that was like
Well, this is the original, but they want the derivative. So anytime I take the derivative of anything that's quadratic, it's going to go over x squared is 2x. It's not, so if, I don't know, maybe I don't understand the question. Yeah, like the square just goes away, right? Because anytime you take the derivative of anything that's squared, it goes down by 1. So there's not going to be a square anywhere. Not for cosine. But I mean, obviously, that's the argument for that.
I get how we did that, but why is it there?
Why is it what?
The one thing that Jason was on is supposed to be that is the virgin desire. So why is that one in the equation? I can't even lie. I look he giggled a little bit. He looked at them.
Well, I'm using my chain rule. What's the derivative of x squared? 2x. I could have said this is u instead of, you know what I mean? And I would have gone with y squared. And then I would have said, okay, what's the derivative of u? Well, that's cosine, so the derivative of cosine is negative sine x cubed plus x squared, and then chain rule times 3x squared plus 2x. So here's my chain rule, bring the 2 down. Here's my original, leave it alone, because it's the inside. And then times the derivative of the inside. And then that has an inside, times the derivative of that. Times the derivative of that inside.
Okay, so it's still
Yeah, because you got 2, like, you know what I mean? Like, you got this, and then you got this on the inside. So the derivative of cosine is negative sign, and then you got to do the derivative of this inside, the argument. So it's like that's how we were talking about, like, when, like an M&M, like, work your way outside in. She said elephant.
Why did the cosine? I'm so confused. Why did the cosine?
Never mind, guys.
Like, why do you still have cosine? Like, you know what I mean?
Because you leave the inside alone, miss. It says right here. Look, it's right here. Check it out. Miss Houston. Look, you see the g of x? It's right there, g of x. It's by itself. Look, derivative of the outside, leave the inside alone, times derivative of the inside. So, it's not squared anymore. I brought the 2 down. Yeah, because I brought that 2 down. I leave the inside alone, like they told me. And then I took the derivative of the inside. Yeah, I got to keep it. That's my inside.
Oh, you do the inside of the inside. Oh.
Yeah, derivative of the outside. You're working your way in. You're working your way in. All right, guys, here we go. This is kind of like a review. This is actually a really good review. Maybe we'll have an exam similar to this. d dx of 2f of x. The derivative of 2f of x is just 2f prime of x. Yeah, you just took the derivative. Evaluated at x equals 2. Equals 2. What's f prime of 2? I just look at a table. 1/3, no? Oh, you're giving me the answer already? Yeah, that's fine. 2/3. Do you guys see how we did it? D dx of f of x plus g of x. What's up, Kyle? Like I'm used to like saying what's going on. Like, what's up, Miss Elephant? About no, like because you told me to eat elephant. I can't. Yeah. Sorry, Miss. What's up? Okay. Yeah, I didn't think about it until I just said it, and then yeah, I apologize. We have fun here at YWLA. Stop. All right, there it is. F prime of x plus g prime of x. I just took the derivative. I put a line. That just means evaluated at x equals 3. What's f prime of 3? 2 pi. Plus, what's g prime of 3? That's the answer. Done.
Amazing, beautiful.
Are we okay? What rule do I need for letter C? Product. Look, it's being multiplied. Yeah, we're taking derivatives. That's a dot that's being multiplied. Evaluate. I guess I should have read the instructions right. Suppose that the functions f and g and their derivatives have the following values at x equals 2 and 3. Evaluate the derivatives with respect to x of the following combinations at the given value of x. So we're taking derivatives here. So here it is, product rule. First times derivative of the second plus the second derivative of the first. It's up to you whether you want to put x. That just means with respect to x. I could have done f g prime plus g f prime. Are we ready? Evaluated at x equals 3. So here it is. I put an equal sign, and now I'm just going to evaluate. So f of 3. So let's go to the table. What's f of 3? 3 times g prime of 3, 5, plus g of 3, -4, times f prime of 3, 2 pi. So let's see what we have here. 15 minus 8 pi. Yep. What rule do I need for letter D here? Okay, so I'm running out of space. So I'm just going to do that to get my correct notation. Quotient. So I'm going to go bottom, derivative of the top, plus or minus? Minus what? Perfect. Bottom derivative of the top minus top derivative of the bottom all over bottom squared. Evaluated at x equals 2. All right, here we go. G of 2. 2. Okay, you guys help me out. F prime of 2. -1. 1/3. Okay. 1/3. Minus f of 2. 8. G prime of 2. All over g of 2. G of 2. 2. All right, let's see what that is. Am I going to be able to fit it? Do I got plenty of space? I'm going to need that space. So let's see. 2/3 plus 24 over 4. So I'm going to turn that 24 times 3 over 3. Let's see. 2/3 plus 25, 25, 25, and then 3, 72. Yep. 72 over 3 over 4. 72 plus 2. So I see 74 over 3 times 4, 12. And that reduces to 6 in the bottom. 37? 37, 37. There it is. And 6 doesn't go into 37, right? Yep, there it is. We're good. Cool or not cool? Yeah, now we're doing arithmetic here. All right, letter E. What rule?
Oh,
That's the one we just learned.
the chain.
Chain. Derivative of the outside, leave the inside alone, times derivative of the inside. We're going to do this, evaluate it at x equals 2. So here we go. F prime g of 2 times g prime of 2. F prime, what's g of 2? 2. That's by coincidence. I wish it wouldn't have been that. Times g prime of 2. What's f prime of 2? F prime of 2 is 1/3. And g prime of 2, negative 3. So negative 1. How are we feeling, guys? Yeah, that's what we're practicing a whole bunch right now. Chain rule again. I'm going to change colors so we can fit it here. D dx of square root of f of x. I'm going to rewrite it. Yeah. Let's write it into exponent form. What's the square root of f of x mean? Yeah, so d dx of f of x. Let me put a parenthesis right here in orange. 1/2. All right, let's see what that is. I'm bringing the 1/2 to the front. Leave the inside alone. What power? Negative half. Am I done?
No.
Times what? F prime of x. I guess if you wanted to say times 1, I guess you could. The derivative of x is 1. All right, let's make it pretty. Before we start doing all this mumbo jumbo, f prime of x is on the top. 2 goes to the bottom. Negative half goes to the bottom. 2 square root of f of x. Does everyone see how we got that? Evaluate this at x equals 2. What's f prime of 2? 1/3. I trust, miss. 2 square root, what's f of 2? 8. 8. All right, let's see if we can make this better. So I have a 1/3 in the numerator. The square root of 8 is 4 times 2. The square root of 4 is 2. 2 times 2 is 4. So 4 square root of 2. So, bless you. 1 over 4 times 3 is 12. So 12 square root of 2. And multiply this by square root of 2 times the square root of 2. We wanted to rationalize it. I guess you could leave it like that, right? So let's see. 2 square root of 2 over 12 times 2, 24. There's my answer. Square root of 2 over 24. If you wanted to rationalize it. Square root of 2 times square root of 2 is 2, no? And then 2 times 12. How are we feeling, guys? Okay. Last two. We're just having a good old time here. Elephants and house stuff. All right. We're going to bring this up. So d dx of g of x to the negative 2. Y'all ready? Sure. What do I do first? Negative 2, open parenthesis, g of x to what power? Am I done? No. Times the derivative of the inside, so I write what? G prime of x. Perfect. Rewriting it to make it pretty. Let's see. Negative 2g prime of x is in the numerator. In the denominator, it's going to be g of x raised to the power 3. This evaluated at x equals 3. You guys ready? Here we go. I'm slowing down. Negative 2 times g prime of 3. I don't know what g prime of 3 is. And you guys help me out. What is it? 5? All over g of 3. What's g of 3? Negative 4 to the third power. So let's see. Negative 10 in the numerator and negative 64. Yeah, 4 times 4 is 16. 16 times 4 is 64. Negative divided by negative is a... And this reduces to 5 over 32. Yay or nay? Okay. All right, this one could get ugly. It's probably the ugliest one so far. There's a whole bunch going on. So I'm gonna just get rid of these x's there because that just means a function of x to make it easier for you. So I'm gonna go. Let me start with blue. I'm gonna start writing up here because I have a feeling I might take up the whole thing. D dx of open parenthesis here. F squared plus g squared close to the what power? 1/2 close. I just rewrote it. Are we okay? Okay. Equals 1/2 in the front. Giant parenthesis. F squared plus g squared close it to the what power? Negative 1/2 times, am I done? No. Open parenthesis. 2 f. Nope. Nope. Okay, look. Can you see it now? Can you see it now, Mr. Krabs? No. 2, leave the inside alone. 2, leave the inside alone. To the power 1 times. Oh, you don't see it. Still don't see it. Okay. Side note. D dx of f squared is 2f times f prime. Yeah, guys, I just didn't put a parenthesis, and you guys got tricked. 2 on the outside, leave the inside alone. The inside is an f.
Wait, but like
Since confusion.
Because like we didn't do that in the last problem.
Oh, because it didn't have a power 2.
Wasn't it g squared of x?
So there's 2 inside.
See, the g of x was by itself to the power 1 here. So we didn't need it. Times the derivative of the inside. Okay, look. Let's do it again. But this time I'll put parentheses so you can see. Look at this, guys. Look at this. F of x. And then look what I'm doing. Putting a 2 on it like that. All right. Tell me what this derivative is. Just f of x with it squared like that. 2f of x times f prime of x. Yes, chain rule. Do you guys see that or no?
I still don't see like what it had to do with that.
Because I got to do the derivative of the inside. 2f and then derivative of the inside, f prime. My inside is f of that inside. I have a lot of insides in here. Look, you just told me this answer right now, Miss Houston. Was it you? Yeah, look, that's f of x squared. Well, that's f of x squared also on the inside. Look, this answer, that's f of x squared. I just took out the x. Kyle, you see it? Oh, okay, you've always seen it. Because times f prime. Am I okay, guys? Plus 2g times g prime. Good. Now we're cooking. Let's see. Do we have anything else? Nope, that's it.
Are we actually cooking or are we just speculating?
I don't know. Well, microwave uses electromagnetic waves, and that's like, that separates electrons from your. Okay, I'll stop. The way a microwave works is amazing, by the way. All right, here we go, guys. I'm going to write it down here. This is the numerator. This is the denominator. So here's what I have. 2f, f prime, plus 2g, g prime, over 2. And then look, this says negative half. So when I bring it down, it's a half. And then half means what? Square root f squared plus g squared. Yeah, I'm slowing down. What can I factor out in the numerator? 2. Can I cancel that 2 with the 2 in the denominator? Hell yeah, I can.
Whoa. Wait, I thought we couldn't cancel it out if there was addition.
I factor it out, miss. It's a product. Look, I'll show you, miss. No, I want you to see it. I want you to see it, Houston.
Oh my God.
There's a safe space, I promise. See? I'm not yelling.
It's off the video. Don't play.
Yeah, I'm not yelling. I was just super excited. Okay. There's a safe space, YouTube. Don't worry. Okay, what's the next question? We got it, guys? All right, here we go. I'm going to evaluate this at x equals 2.
Can we take the square root or no?
Yeah, well, eventually. We'll see if we can. What's f of 2, guys? 8. What's f prime of 2? 1/3. Plus, what's g of 2? 2. What's g prime of 2? All over square root. Let's see, f squared was 8, so 64. Plus g squared was 2 plus 4. Yay or nay? All right, so let's see what we have. 8/3 minus 6 over square root of 68. We're still okay? All right, I'm going to take my little calculator here. I'm going to do my little hack. I'm just going to go 68 divided by x. And I'm going to be looking for a perfect square root. Right there, 4 and 17. Do you guys see what I did? So this is 4 times 17. What's the square root of 4? So I'm going to go ahead and multiply this one already by 3 over 3. Bless you. So 8 over 3 minus 6, 12, 18. 18 over 3, all over 2, square root of 17. So negative 10 over 3 over 2 square root of 17. Negative 10 over 6 square root of 17. Does everyone know how I got here?
Yeah.
Times square root of 17 over square root of 17. So let's see, my final answer. Negative 10 square root of 17 over, I guess I should have reduced that, but no big deal. 6 times 17, we'll reduce it right now.
Wait, I know. 42 something. It ends with a 2.
And then that we can reduce. 2 goes into 10 5 times. So negative 5 square root of 17 over 51. Did I do that correct? I make mistakes all the time, so. Six and 17. I don't know why I don't like that, but that's fine. All right, what do you guys think?
That was the funniest lesson we had in a while.
All right, we're done, guys. Take care of Delta.